Hello everyone, welcome back. My name is Mr. Cobalt, and in this problem we're going to find out how many grams of octane does it take to react with all the air in a cylinder in your combustion engine. Let's get into this. So, octane, which is a component of gasoline, reacts with oxygen according to the following equation. So here we have 2 moles of your octane. This is your octane CH8H18. Reacts with 25 moles of oxygen gas, which is then going to give 16 moles of carbon dioxide and 18 moles of water. So in this problem, we're going to assume that the volume of one cylinder in an automobile engine is 500 cubic centimeters. If air enters the engine at 50 degrees Celsius and 1.0 atmospheres of pressure, how many grams of octane should the fuel injection system send to the cylinder in order to completely consume all of the oxygen in the air? So we're going to assume for this that the mole fraction of oxygen in the air is 0.20. Okay, so let's get into this. So first of all, you're probably wondering, like, how in the world am I going to use the mole fraction when I don't have any moles, right? Or how is that going to help me in this problem? Well, first thing you want to know is, of course, your mole fraction is represented by the Greek symbol chi. It's a very ugly Greek symbol, but bear with me. So here, your mole fraction is equal to the moles, and that's represented as N. The moles of your gas that you're interested in divided by, or the substance you're interested in, divided by the total moles in your mixture, right? So that's what the mole fraction is. But when we're talking about gases, we also know that your partial pressure of your gas A is also equal to the mole fraction of A multiplied by the total pressure. So this is also true, right? Okay, so this would be mole fraction of A. So this is going to help us in the problem because now we can solve for the partial pressure of A. And what's A? Oxygen. So what do they give us in the problem? Let's list it out. So they assume the volume of one cylinder is 500 centimeters cubed. Okay, so volume is equal to 500 centimeters cubed. Okay, what else do they give us? They give us that the air enters the engine at 50 degrees Celsius. So we got temperature. 50 degrees Celsius. Let me double check to make sure I have the right units. Yes. So 50 degrees Celsius. And they say that the air entering the cylinder is 1.0. Now that's something to keep in mind because here we're talking about 1.0 atmosphere pressure for the air, not the oxygen, but we're interested in the oxygen. So that's where this is going to come into play. So the partial pressure, we're interested in the partial pressure of oxygen. And that's going to be equal to the mole fraction of oxygen multiplied by the total pressure. What is the total pressure? that is the pressure of the air that they give us, which is 1.0 atmospheres of pressure. So then the partial pressure of oxygen is going to be equal to the mole fraction, and they gave us the mole fraction here, 0.20, 0.20, and we're going to multiply that by 1.0 atmospheres. And of course, 0.20 multiplied by 1 is going to be 0.20. So we have the partial pressure of oxygen is 0.2 atmospheres. And so now we have the pressure of the oxygen, which is 0.20 atmospheres of pressure. Okay, so now that we have that, we can now use the ideal gas law to convert and figure out how many moles of oxygen reacted with the octane. Because octane is reacting with the oxygen, if we can figure out the number of moles of the oxygen that was consumed, then we can use stoichiometry to convert the amount of oxygen to the amount of the octane, and therefore then use the molar mass to convert to the grams of octane, the mass of octane. But first, what we need to do is we need to make sure that the units here are such that they will cancel out with the units in the ideal gas law constant, so that way everything cancels out. So we need to convert volume into liters, and so let's do that. So if we take 500 centimeters cubed, we know that let me erase this so we can get this out of the way. Now that we're done with this, we know that 1 centimeter cubed is equal to 1 milliliter. So we'll put 1 centimeter cubed on the bottom, 1 milliliter on top, so centimeters cubed cancels out. And now we can convert to liters, which is what we want. So 1 milliliter on the bottom, that's equal to 1/1000th or 10 to the negative 3 liters. So now milliliters cancels out. And when I calculate this, I get 0.500 liters. So now this is equal to 0.500 liters. Let me double check that. Yes. Okay, so now I'm going to change the temperature from Celsius to Kelvin by adding 273.15. So I'm going to add 273.15, and that's going to be equal to 323.15 Kelvin. Let me double check. 323. Okay, so now I have the temperature in the right unit of Kelvin. I have the volume in the right unit of liters. Pressure is in atmospheres. That's the right unit. Now I can use PV equals nRT. I'm going to solve for N. So N is going to be equal to PV over RT. And now I just plug in my pressure. So pressure is 0.20 atmospheres. Volume is 0.500 liters. 0.500 liters. R is going to be 0.08206, and that's going to be liter atmospheres over Kelvin mole. And we're going to multiply by the temperature, which is 323.15. So 323.15 Kelvin. And you see that the atmospheres cancel out, liters cancel out, Kelvin cancels out, and we're left with moles, which is what we want. So when we calculate this, we get 377,107. Let me erase this. So this is going to be equal to 0.003. What did I have? 77. Oops. 107. Now, of course, I have a lot of digits. Oh, I forgot. Moles of oxygen. All right, so I have a lot of digits here. You don't need all these digits. Remember your sig figs when we're looking at sig figs here. So here we have 3 sig figs when we converted to liters. Here we should have 3 sig figs because remember the least when we add the number of sig figs here is dependent upon the number of decimal places. So the least number of decimal places is what we go by. So this has 0 decimal places. So we cut it off after there. But we kept the 0.15 to avoid rounding errors. And here we have 2 sig figs in our atmospheres. And so the least number would be 2 sig figs. So we'll underline that. We'll keep the rest, or you can keep it, 1 digit is fine if you keep an extra digit. I like to keep more. So now that I have the moles of oxygen, I can use the balanced equation to convert moles of oxygen to moles of the octane, and then convert moles of octane to moles or grams of octane using the molar mass of octane. So let's go ahead and do that. So I have 0.003771 moles of oxygen over 1. The mole ratio between oxygen and octane is 25:2. So I'm going to put 25 moles of oxygen on the bottom, 2 moles of the octane on top. Moles of oxygen cancel out. Now I'm going to use the molar mass to convert from moles to grams. So I'm going to put moles on the bottom. So I have 1 mole of the C8H18 octane, and the molar mass is 114,232, 114.232 grams of C8H18. Moles of the octane cancel out. Let me just double check that I have that correctly. Yes. So now that I have grams of octane, I just multiply across the top, divide by the bottom, and I get the number of grams, which is 0.034 grams of the octane, C8H18. And again, remember I only have 2 sig figs available here. So remember I should only have 2 sig figs. So this has 2 sig figs here. This is exact. This has 6 sig figs. So the least number is 2. So therefore my answer should have 2 sig figs. And so that's the answer, and the proper number is sig figs. I hope you enjoyed this video. If you enjoyed this video, if this helped you in any way, then please by all means like the video, share the video, hit that like button over here or over here somewhere. Also, do me a favor, subscribe to the channel, hit that notification bell. When you do, make sure you click all. And when you do that, make sure you click, click all. So that way you can be notified by all the videos that I put out. And then finally, put a comment down below in the comment section. Let me know what you think. Hold on a second. Sorry about that. I didn't want to do that in the dark. Put a comment down below in the comment section. Let me know what you think. Ask me questions. I would love to hear from you. If you have a question or problem that you need help with, put that down below. If you have a if you have a topic you want me to cover, put that down below. I would love to do that for you. Thanks for joining me and have a great day.